Vanakkam. Welcome to this course on classics in neuroscience. In this series of videos, we are looking at classic Nobel Prize winning works. In this series, we will start looking at the classic Nobel Prize winning works of Hodgkin and Huxley. In this video, we will look at the background, this action potential and the definitions and the basics, which was the work of Hodgkin and Huxley, and the crucial importance of the method that was developed by Hodgkin and Huxley and their model, and biographical background of Alan Hodgkin and Andrew Huxley. What we know is that the central nervous system, the nervous system, is responsible for transmitting signals throughout the body, essentially is responsible for communicating information throughout the body, between different parts of the body, between different regions. Nerve impulses or action potentials are essentially the fundamental units of communication in neurons. How does this fundamental unit of communication happen? That is the question. Before the work of Hodgkin and Huxley, there were some theories, most of which were speculative. There was not clear qualitative and quantitative description or explanation of what constitutes communication within a neuron. This is, for the time being, only communication that happens or information transmission that happens within a neuron. What happens between neurons is the subject of future videos. For now, we restrict our attention to communication within a neuron. So, understanding how this communication happens is through action potentials is critical for deciphering how brain and nervous system functions. For understanding the basics, I recommend you to look at my other course, Neuroscience of Human Movements, where I describe in detail of how action potential happens. What is the action part of action potential? What is a graded potential? What is an action potential? What is the action part within action potential? I describe. I will post the links in the description. So, these are essentially very quick changes in membrane potential that cause propagation along the plasma membrane. For some reason, changes that happen in the membrane potential that happen too quickly appears to propagate from one part of the axon to another end of the axon. So, how or why this happens, how does this happen is beyond the scope of this course. But it seems like suppose I have this neuron and I have an action potential like this, that is a let us call this a neuron. This is the nucleus and the axon and the dendrites, for example. These are the dendrites, for example, and an action potential is starting here. After some time, another action potential here, another action potential there, another action potential there, leading to this unidirectional communication. The details of how this happens I have presented in my other set of videos. Please do watch those. So, several hypotheses regarding how this happens were present before Hodgkin and Huxley came into the scene, but many of these were speculative and did not provide evidence. See, in science, for all these things you need evidence, not just stories. So, one hypothesis was that this was due to the movement of ions through specific ion channels, but where is the data? It was not there. Hodgkin and Huxley was the first to mathematically describe, quantitative description of this phenomenon was first provided by Hodgkin and Huxley. Essentially, the contribution is providing quantitative description of the movement or transmission of neuronal impulses, provided insights into the mechanisms by which this transmission happens, and essentially and completely revolutionized the field of neuroscience and electrophysiology. An entire new field of electrophysiology was practically started by Hodgkin and Huxley, and these are still considered top-notch fields, top-notch techniques in the field of electrophysiology. Hodgkin was born in 1914 in UK, in Banbury in United Kingdom. He passed away in 1998 in Cambridge. He was affiliated to University of Cambridge in UK. Essentially, he was awarded this Nobel Prize for his discoveries concerning the ionic mechanisms involved in the excitation and inhibition in the peripheral and central portions of the nerve cell membrane. Huxley was born in 1917 in Hampstead in the United Kingdom, and he lived up to 95 years and passed away in 2012 in Grantchester in the UK. He was affiliated to University College London in the UK and also awarded for the same discovery, for his discoveries concerning the ionic mechanisms involved in the excitation and inhibition in the peripheral and central portions of the nerve cell membrane. Recall some of their histories we have discussed in previous set of videos, perhaps in the early weeks of this course, and please do review and revisit some of them. The details I am skipping for want of time. That stories about Andrew Huxley's grandfather and so on and so forth are all there in the previous set of videos. With this, we come to the end of this video. Thank you very much for your attention.